Welcome back to Daily Dose of Space. For as long as we've been observing the universe, we've relied on patterns. Stars behave in certain ways, galaxies evolve on predictable timescales, and extreme objects usually leave behind signatures that point clearly to what they are. But every now and then, something appears that refuses to follow those rules. Not because it is hidden or poorly observed, but because even under careful scrutiny, it does not fit into any category we know. The more data we collect, the more uncomfortable the picture becomes. Tonight, we are focusing on a single object, not a class of objects, not a theory. One object that has been observed for years across multiple wavelengths by different instruments and still cannot be fully explained. An object that refused to stay consistent. The story of this object did not begin with excitement. It began quietly, buried in archival data that astronomers routinely revisit in search of overlooked phenomena. At first glance, the source appeared to be a transient event, the kind that briefly brightens and then disappears. These are common in astronomy, especially when observing deep space. Supernovae, stellar flares, and accretion events around black holes all leave behind temporary signals. What made this object different was not its initial appearance, but what happened when researchers started looking backward in time. The source had been there before. Earlier observations showed the same location producing light, then fading, then returning again years later. The changes were not subtle. In some observations, the object appeared remarkably bright, while in others, it was almost completely absent. This behavior immediately narrowed the range of possible explanations. Large structures, such as galaxies, do not change significantly on short timescales. Their combined light comes from billions of stars, which smooths out rapid variability. Objects that change quickly must be relatively compact. And yet, this object was extremely distant. Its light had traveled for billions of years before reaching Earth, meaning the energy involved was enormous. This combination posed a fundamental problem. Small objects are not supposed to produce that much energy, and distant objects are not supposed to change that fast. From the very beginning, the object was asking an uncomfortable question. Which of those assumptions was wrong? When every explanation falls apart. As astronomers began targeting the object more deliberately, the situation became even more confusing rather than clearer. Observations across different parts of the electromagnetic spectrum revealed behavior that seemed inconsistent, even within itself. At times, the object emitted strong X-rays, suggesting extremely energetic processes. At other times, those emissions were weak or absent. Radio observations occasionally detected activity, but not in any regular or predictable way. Naturally, scientists tried to match the object to known phenomena. A supernova was quickly ruled out, since supernovae do not return after fading. A pulsar was also unlikely, because pulsars are among the most stable and precise objects in the universe, behaving almost like cosmic clocks. Active galactic nuclei were considered more seriously, since they are powered by supermassive black holes and can vary in brightness. However, even this explanation struggled. Active galaxies usually sit neatly at the centers of their host galaxies, where supermassive black holes are expected to reside. This object appeared offset from the galactic center, in a position that did not align well with existing models. Moreover, the pattern of variability did not match what astronomers typically observe from accretion disks around black holes. The object seemed to switch between states that should not coexist so easily. At this stage, the mystery deepened rather than narrowed. Each new observation removed some possibilities while introducing new contradictions. The object was not simply unknown. It was actively undermining the frameworks used to classify cosmic phenomena. Rather than converging on an answer, researchers found themselves circling the same question from different angles, each time reaching a different dead end. A window into what we're missing. Eventually, astronomers began to consider a different possibility. Instead of assuming the object belonged to a known category, they asked whether it represented something transitional, rare, or short-lived that existing surveys were simply not designed to detect in large numbers. One leading idea involves intermediate mass black holes, a long-predicted but poorly observed class of objects that would fall between stellar mass black holes and the supermassive ones found at galactic centers. Such objects could, in theory, explain both the rapid variability and the extreme energy output. Yet even this explanation remains incomplete. While it resolves some aspects of the mystery, it fails to account for others, particularly the irregular emission patterns and the object's precise location. Another possibility involves unstable accretion processes, where matter falls toward a compact object in bursts rather than in a steady flow. In such scenarios, the object's brightness could rise and fall dramatically, depending on the chaotic behavior of its surrounding environment. What makes this object particularly important is not just its strange behavior, but what it implies. If this object represents a brief or uncommon phase in cosmic evolution, then many similar objects could exist undetected, hidden in existing data, because they do not behave long enough to be easily classified. That would mean our inventory of the universe is incomplete in a fundamental way, not because we lack technology, but because we have been looking for the wrong patterns. The most mysterious object ever observed in space does not challenge science by being unknowable. It challenges science by refusing to fit neatly into the categories we rely on to understand reality. Over time, this mystery will likely be resolved. New observations will arrive, better instruments will refine the data, and patterns will eventually emerge. But until that happens, the object serves an important purpose. It reminds us that the universe is not obligated to follow our expectations, and that discovery often begins not with answers, but with contradictions. Sometimes understanding advances not when something makes sense, but when it very clearly does not.